pick up any newspaper today or listen to the news, you might well be very despondent at the state of the world. Maybe the 4 horsemen of the apocalypse are on their way. For pestilence, read global warming. War, we have Russia invading Ukraine. Famine, Ethiopia, Yemen, Malawi and many others. And death, the recent COVID epidemic. However, I am personally more optimistic and hope to persuade you over the next 40 minutes or so that not only is there a lot of hope for the future, but overall we have more opportunities for better lives than any earlier generation. We have more discretionary time and longer, healthier lives. There is a lot to be thankful for, but further we can go and we can all play our part. You must remember that the basic state pension introduced through the National Insurance Act of 1946 paid men at 65 and women at 60, when most women only got the widow's entitlement and most men only lived to collect 3 years of pension. Average UK life expectancy has increased a further 18 years since then. This increase in life expectancy is due to, in a large part, to health improvements, which would not be possible without the engineers who designed and built the equipment needed for medical devices, imaging, mass production of vaccines, clean water, sewage treatment plants. I could go on. My title today is Enlightened Engineering, The Path of Progress, and I aim to show you what I see as enlightened engineering and how this will help us progress as a country, as a society, and as a global population. Let's start with enlightenment. So what is it? Well, Immanuel Kant, a 17th century German philosopher who was one of the key Enlightenment thinkers, saw it as humankind's emergence from its self-incurred immaturity. So enlightenment equating to maturity, and that progress each age comes from extending our insights, increasing our knowledge and purging our errors. His motto was "Dare to understand," which was underpinned by the demand for freedom of thought and speech, and sounds pretty good to me. Adam Smith, he of The Wealth of Nations, who was a contemporary of Kant's, wrote that an abundance of useful stuff cannot be conjured into existence by a farmer or craftsman working in isolation. It depends on a network of specialists, each of whom learns how to make something as efficiently as possible, and who combine and exchange the fruits of their ingenuity, skill and labour. He calculated that a pin maker working alone could make almost 1 pin per day, whereas a workshop in which, quote, "one man draws out the wire, another straightens it, a third cuts it, a fourth points it, and a fifth grinds it at the top for receiving of the head," could make almost 5,000 pins a day. Perhaps this is the first example of work study or methods time measurement. It goes to show that sharing knowledge, learning from ours and others' mistakes, is a crucial part of enlightenment and is how we make progress for engineers and society. Robert Stevenson wrote that nothing was so instructive to the younger members of the profession as records of the accidents in large works, more valuable than a description of the most successful works. He goes on to say that engineers derived their most useful store of experience from the observations of those casualties which had occurred on their own and 2 other works, and it is most important that they should be faithfully recorded in the archives of the institution. He may have been talking about the Institution of Civil Engineers or the Institution of Mechanical Engineers, as he served as president to both those illustrious organisations. The key sentiment of sharing best practice, learning from mistakes, and continuing professional development are key for all the institutions today. One of the things you will have noticed about my 3 leading lights that I have quoted so far, they're all white men. These are the people who had the opportunities, education, and platform for history to remember them. The women of the time are often shadowy figures, only mentioned as wife of. Women whose days were spent in cooking, cleaning, washing, hard physical labour. And if they had paid employment, that was generally hard physical labour too. There was little time or energy left for reading, thinking or learning. Thankfully, the enlightenment that has taken place during my career recognises the varied inputs of a wider range of people to make a broader contribution to society's progress. Some of this progress has meant that women have more time to make meaningful contributions through the invention and development of labour-saving devices such as washing machines, irons, central heating, indoor plumbing, etc. I remember my mother being thrilled with a twin-tub washing machine, which, while it made washing clothes much easier, still meant that she had to stand over it for an hour or so while it did its thing. And at that stage, my mother was a full-time teacher with 2 small children and a house to keep. It was unthinkable that Dad would do washing, but he had used to send his collars out to the laundry to make Mum's life easier. Do you remember the sensation that was the first Bry nylon shirt? No ironing needed, no detachable collars, but they created huge amounts of static and would cling badly. They are so part of the 70s, and again labour saving for women. Only by being freed from the tyranny of domestic drudgery can women play a full part in the progress of our society. This graph shows the use of basic household appliances and how it has reduced the number of housework working hours per week from around 18 hours for my mother to less than half of that today, and way less for me personally, which is probably a contributing factor to me standing here before you. The next few graphs, including this one, come from one of my favourite websites, Our World in Data. As an engineer, I like data, and so it's one of my best places to go, and I recommend it to you. If you look at the lower graph, you can see how housework was a full-time job up until the 1930s. So there was no capacity for most women to enter the workforce. They were already working full-time. This graph shows the adoption of various technologies, the things that we now take for granted and can't imagine living without. Remember that the first mass-market smartphone, the original iPhone, was released in 2007, only 15 years ago. I was fortunate enough to be provided with a mobile phone as part of a job that I had back in the early 1980s. It was the size of a briefcase and sat on the passenger seat of my company car. It actually had a rotary dial, so you would dial the numbers and then hold the handset up. When my manager gave it to me, he told me to take great care of it, never to leave it in the car overnight, as it was worth significantly more than the car was. These inventions, mass-produced by innovative engineers to make them affordable and now a necessity, give us increased amounts of leisure time, the like of which no other generation has had, unless of course you were in the 0.1% or less of the population that was wealthy enough not to have to work. We can generally look forward to around 320 minutes a day to be spent on leisure activities by men, and about an hour less at 270 minutes a day by women. There is still a significant gender gap, but we all have much more leisure time than our parents did, and this has to be a good thing. I was fascinated by a book I've been reading recently by Steven Pinker, and he quotes that back in the 1960s, several thinkers advised that the greatest threat to the human species were overpopulation, nuclear war, and you'll never guess the third one, boredom. One scientist warned that the first 2 might be survivable, but the third one definitely would not. As people no longer have to work all day and think about where their next meal is coming from, quote, they will be at a loss as to how to fill their waking hours and will be vulnerable to debauchery, insanity, suicide, and the sway of religious and political fanatics. How scary is that? If we look at how the leisure time we have is used, you can see that it gives us the capacity to do the things that we enjoy. The things at the bottom of this chart are rated higher for happiness and cover a lot of the activities that we do as part of the Worshipful Company of Engineers, such as visiting with friends, eating out, parties, hobbies, going to the theatre and concerts. So we now have more leisure time to spend on the things we enjoy, as well as better health and longer life expectancy. So we've never had it so good. Whatever the doom-mongers who write news headlines have to say, and the short-term political and financial chaos that we're currently living through, we have successfully solved the boredom crisis and are instead experiencing the Chinese curse of living in interesting times. My career in engineering started the same year as the company was founded, and I'm very pleased to say that apart from a few raised eyebrows when I said I wanted to be an engineer, my family and school didn't really put any obstacles in my way. The one piece of advice that my dad gave me was, don't go into industry, which needless to say, I didn't take. When people say to me, what can we do to get more women in engineering? I have to think of my nan, my paternal grandmother. She was born in 1901 to a mining family in the Black Country, the 9th of 13 children, and as a teenager she won medals for high jump and cross-country running, which was most unusual at the time. My nan left school during the First World War and became a saddle stitcher in the leather industry, which took her to the Velocet and then the BSA, the Birmingham Small Arms Company, where she stitched holsters for pistols and then after the war, saddles for motorbikes. In this photo you can see my nan with a couple of her friends having taken their ladies' bikes, and at that time anything under a 500cc engine was considered to be a lady's bike, to Weston-super-Mare for a day at the beach. So this photo would have been taken in the early 1920s. My nan is the one furthest away from the camera. She met Grandad at the BSA and they courted for over 10 years as she didn't want to give up her independence by getting married and rather enjoyed earning her own money. Eventually Grandad gave her an ultimatum and took her to look around a new house that he had bought, so that if she didn't marry him and move in as his wife, he was going to move his mother in as housekeeper and there would be no getting her out again. As was the way back then, Nan had to give up work the day she married. Getting girls involved in engineering takes a couple of generations and is still going strong today, as I was delighted to be introduced to two of their granddaughters by Past Master O'Reilly and Christine at the Mansion House banquet only last week. One of them is heading to be an engineer and the other a lawyer. This photo is one half of my graduating class, the mechanical engineers from Coventry University. Can you spot me right in the middle? I'm the girl with the curly perm that was fashionable then. We're all standing on the steps of Coventry Cathedral. There was one other girl in the picture. She's standing just behind me. We were 2% of the mechanical engineering degree class at Lanchester Polytechnic. 2% being somewhat lower than the average percentage for women doing engineering at the time. But then mechanical engineering has always been a bit behind in terms of the number of women it recruits, compared with some of the cleaner branches of engineering, such as electrical, electronic engineering, or the more outwardly socially beneficial, such as civil engineering. This graph shows the percentage of women in STEM from 1960 to 2021. You can see how engineering is much lower than other STEM subjects. Things are improving in engineering, but very slowly. Will we ever get to 50-50? Well, according to Cheon Wura, one of our guest speakers at the banquet, she's a Labour MP now, but was originally an electronics engineer. She quoted 2344 as the date when we're scheduled to get to gender parity in engineering, based on the current rate of growth. However, I've taken part in some recent doctoral research looking at how we take our authentic selves to work as engineers. Questions such as, does being an engineer affect how you present as female or male? Do you have to compromise your identity as a woman or man to be an engineer? How accepted do you feel by your colleagues as a man or a woman? Working on the basis that we have to be our best selves at work, we need to be in a supportive, inclusive and accepting environment. Helen Johnson, the researcher that's carrying out this doctoral research at Loughborough University, wrote an article for the Institution of Mechanical Engineers back in August. She states that it will take up to 21-24 for there to be the same number of women as men working in engineering, and it could take 50 years for the proportion of ethnic minorities in engineering to reach the overall proportion of ethnic minorities in employment. Let's have a look at how the Worshipful Company of Engineers fares as regards percentage of women. So the company was founded in 1983. It took until 1988 to get their first lady. That was Baroness Platt of Writtle, Baroness Beryl Platt. Two other ladies joined between 1988 and 1998, the next 10 years. Then in 1998, the then master, Dr. David Mitchell, persuaded the company to hold a luncheon to which all the female fellows of professional engineering institutions were invited. At that time, I believe there were around 200 female fellows across all the institutions. About 40 ladies attended the lunch, which resulted in 7 of us joining the company, including our current master, who is 8 ahead of me in number order and never lets me forget it, and me. Today we have 36 female members of the company across the Livery and the Freedom, so approximately 10%. While I was looking for a photograph of David Mitchell, I came across this quote from him in Commander Brian Gibson's book, A Well-Engineered Company, about the first 25 years of the company's history. I'll give you a minute to read it, but it strikes me as just as true today as it was over 20 years ago. Here I am on my first visit to the Institution of Mechanical Engineers at One Birdcage Walk. I was the first, and I think only girl, to win the Queen's Silver Jubilee Prize in a competition where I had to give a 20-minute presentation about my final year project. Here I am being presented with a cheque and certificate from a gentleman called Frank Shaw, who was one of the development engineers responsible for putting a gas turbine engine in a rover, a project known as Jet 1, currently on display in the London Science Museum. Frank then recruited me to join the IMechE Prizes and Awards Committee, which he chaired. I was then the token young member, if you can imagine it. Since that time, I have continually served on at least one committee at the IMechE, with a short break for when I worked in China. And it goes to prove the old adage, get 'em started young. The Queen's Silver Jubilee Prize competition was relabelled as Speak Out for Engineering and continues to this day. It continues to challenge young engineers to prove that they can communicate effectively. It is specifically concerned with verbal and visual communication in describing and explaining technical subjects and is now a global competition. This is the project that formed the basis of my talk. It was looking at how to relate objective measures of the vibration transmitted through a car seat to the subjective feeling of comfort by the person sitting in the seat. Up until this time, car seats had predominantly been sofas on wheels, large squashy foam cushions with a covering made of relatively normal upholstery fabric, PVC or leather. This is a standard seat test mannequin of the time, a plastic body that was filled with water to give roughly the right weight for the subject sat in the seat. As you can see, it's a very crude approximation of the human form. Then while I was doing my work, we got hold of this, known as an Endevco mannequin. He looks a lot more human, and I even dressed him in pyjamas for decency's sake. While he had the right weight distribution, as a human does, his joints were very stiff, so still a very crude approximation of the real thing when it came to testing. In this photograph you can see the test rig that I designed and built for my project using state-of-the-art electro-servo hydraulics at Austin Rover's factory in Canley, which is now an out-of-town shopping centre. The only way to get real subjective measures was to use real people, and here is my industrial tutor being my guinea pig. This photo makes me cringe as just how dangerous this could have been and what I as a student was allowed to get away with. There is no way that anything like this could be countenanced today, but thankfully no one was hurt during my research. If you think about the vibrations that go into a car as it drives along the road, most of the vibration is damped out by the suspension, but some of the vibration will still get to the floor pan, the base of the body of the car. This then transmits up through the seat rail into the base of the seat. For subjective comfort in a showroom, soft, squashy seats are what people say they prefer. However, if you then take that car for a drive for a couple of hours, firmer, more supportive seats are more comfortable. This is a common dilemma for the car manufacturer, as still more than half of car buyers buy a car without taking it for a significant test drive, and more than a quarter never test drive it at all. So really the showroom comfort is what sells the car or not. The seat is also your primary safety system, so there is a lot more engineering that goes into a car seat than most people are aware of. They are very sophisticated items that can drive a sale or equally put off a purchase. As a relatively new graduate, I was given responsibility as program manager for what was to be the metro replacement. It never came to fruition due to lack of funding, but it was going to be a world-beating small car, and I was very proud to work on it. We had just completed the design of the seats, with some 2 years or so of fabric testing to ensure that the fabric didn't fade in the sunlight, go brittle in the cold, sag or bag when driven for 100,000 miles, as well as meet all the crash test and fire regulations. Harold Musgrove was the chairman of Austin Rover at the time, having just taken over from Sir Michael Edwards. He took my prototype home for the evening to get a feel for how the car drove. The next day I was sent a terse note that said, "Change the fabric, Mrs. Musgrove doesn't like it." That was 2 years' work down the drain. When designing products for the human body, there are huge databases available. These were in table form when I was doing my university project, and in software database form when I was again working designing car seats back in the 1990s. The information is available on many different populations, which can be used for products in specific markets. Here you can see that the Japanese are statistically much smaller as a population than Americans, which I guess is no real surprise. But you may be surprised at just how much variety there is. As a small female level, there is only a 5 to 7% variation, whilst at the large male end of the scale, the variation is of the order of 15%. One of the key areas of complaint, usually from tall men, is that the seat cushion, the bit you sit on, does not provide adequate support at the back of the knees. The reason for this is that for small women, you have to limit the length of the cushion so that it doesn't dig in at the back of their knees and cut off the blood supply. And you can see from the data given here just how much variation there is in the buttock to knee position, with the 95th percentile male being almost 22% larger than the 5th percentile female. This is a full 120 millimeters, or nearly 5 inches difference. The pictures here on this slide show some of the range of measures that can be accessed from the software that we use for our anthropometric studies. This was called PeopleSoft and has databases of all the measures outlined between the arrows for numerous different populations. Here I've pulled out some of the weight figures to show the variation between 3 different populations: European adults, British adults, and American adults. And you can see that the American range is much wider and encompasses both the European and British populations. Another well-known population variation is that of arm length, where statistically Italians have longer arms than the rest of the European population. And so historically, if a Brit were to drive an Italian-made car, they would probably find the gear stick situated unnaturally far forward. However, with vehicles now being designed for a global market, these variations are becoming less obvious. Women are considered to be small men when it comes to car design. The height and weight is modified for female measurements, but there is no consideration of the different spread of the weight that gives each sex its characteristic shape. This became very apparent when I was doing my student project, as bits of me, the only female test subject, vibrated with a very different resonance frequency to bits of the men, and consequently things that they found comfortable, I found very uncomfortable, and vice versa. There is also a very significant sex difference in motion sickness. Women tend to suffer a lot more motion sickness and a lot worse than most men do. It's thought that one of the key areas causing this motion sickness in cars is exacerbated by cars being designed around the male body. So if the seat is the wrong height or the headrest is inappropriate, then that will cause problems for women. As usual, there is little data or research in this area, and it follows a long and ignominious history of a data gap for women in car design and many other areas. Men are much more likely than women to be involved in a car crash, which means they dominate the numbers of those seriously injured in car accidents. This makes perfect sense when you look at the number of miles travelled in cars by men and women. Most professional drivers are still men, and they clock up many thousands of miles a year. But when a woman is involved in a car crash, she is 47% more likely to be seriously injured than a man, 71% more likely to be moderately injured, even when researchers control for factors such as height, weight, seatbelt usage and crash intensity, and she's 17% more likely to die. And that is all down to how the car is designed and for whom. Women tend to sit further forward than men when driving. This is because we are on average shorter. Legs need to be closer to reach the pedals, and we need to sit more upright to see clearly over the dashboard. This is not the standard seating position. Women are considered to be out of position drivers. Our willful deviation from the norm means that we are at greater risk of internal injury and frontal collisions. The angle of our knees and hips as our shorter legs reach for the pedals also makes our legs more vulnerable. Essentially, ladies, we're doing it all wrong. Back in the early 1980s, researchers argued for the inclusion of a 50th percentile female in regulatory tests, but this advice was ignored. And it wasn't until 2011 that any female crash test dummies were developed, let alone used. There is one EU regulatory test that requires what is known as the 5th percentile female dummy, which is token to represent the whole female population. This dummy is only tested in the passenger seat, so we have no data at all for how a female driver would be affected in crashes. Something of an issue, you would think, given women's out of position driving position. And secondly, you might have guessed it, but this female dummy is not really female at all. It's just a scaled down male dummy. It's a shocking fact that there is more legislation relating to dogs in cars than there is relating to women in cars. More women working in the industry is starting to have an effect on design and standards, as well as the business case of women now making up 62% of all car buyers. This lack of representation in design, regulation and testing on most products means that women are not well served by most mass-produced engineered products. When I started my thin sandwich apprenticeship at Jaguar, the first engineering practice that I carried out on the shop floor, EP2, at that stage there was only one set of ladies' toilets in the factory, and those were in the main reception in the main office block, about half a mile away. So for my 15-minute tea break, I quite quickly realised that I had a choice to make. I could either trot to the ladies, do what needed doing and get back just in time to get back to work, or I could make a drink it and enjoy my 15 minutes tea break. My solution was to learn to whistle, quite tunelessly I might add. I then had a challenge to get to the shop floor toilets first, do what needed to be done while whistling, so that any man who entered knew that I was there, and then they could either take their chances that I may walk out on them, or they could wait. Whilst none of this is as bad as what the lady mathematicians known as computers suffered in the film Hidden Figures, things had moved on a bit since the mid-50s, and there wasn't any racial segregation where I was working. Today this is quite unthinkable. Enlightened offices have non-gender specific cubicles. But I have to say that as a just-in-time specialist, this is a real challenge where we need a high throughput for things such as theatres, sports venues and production lines, where you need to get a lot of people through the toilets in a short space of time. Have you ever wondered why there's always a queue for the ladies while not for the gents? On the face of it, it may seem equitable to accord male and female public toilets the same amount of floor space. And historically, this is the way it has always been done. 50-50 division of floor space has even been formalised in building regulations and plumbing codes. However, if a male toilet has both urinals and cubicles, it is patently obvious that the number of people who can relieve themselves at once is far higher per square metre of floor space in the gents than it is in the ladies. So suddenly, floor space is not so equal. Studies have also shown that women take 2.3 times as long as men to use the toilet, for a whole raft of very good reasons. I imagine that there weren't any women on the standards committee that wrote those plumbing codes. If there had been, things may have been different, and I'm still hoping that it may change. I mentioned this to a friend of mine who gave me another example relating to our kind of formal dinners. She said that for military formal dinners, it is not allowed, or at least deeply frowned upon, for anyone to leave the room between sitting down to eat and the final toast. And some of these dinners may last a number of hours, especially if the speeches go on and on. This can be an uncomfortable struggle to remain seated at the best of times, but she found it particularly difficult and painful when pregnant, to the point of stopping attending these events. Not very enlightened. Luckily, the livery are a little more enlightened, and generally the beadle announces a short break for anyone who needs to visit the facilities before the speeches and toasts begin. You've probably come across the Me Too campaign, which started in 2006 in the theatre and film industry and has extended to many different sectors: politics, medicine, hospitality, journalism, and surely that doesn't happen in engineering. Well, let me tell you that it most definitely did and probably still does, and is also closer to home than you may imagine. When I started my apprenticeship, it was the time when the classiest decoration on the walls in a factory was the latest Dunlop or Pirelli calendar. And as wall art went, it went significantly downhill from there on. As a rather naive and sheltered 18-year-old working on the shop floor at Jaguar, it was a huge learning curve for me, but also character forming. I soon learned who not to be alone with, what days of the week were safe to go to the stores, and when to keep my overalls securely fastened right up to the neck. It was a regular sport for the guys around me to replace my notebooks with porn magazines. And when I went for a tea break, anything could have happened to my workstation when I came back. Whilst I'm pretty sure that such things wouldn't happen today, there are at least recognised people to speak to and procedures to follow should anyone be subjected to such behaviour. I was interested to see how having more women in engineering, and especially teaching engineering at university, has brought about a significant change in the wall art around offices and factories today. Here are two posters that I photographed on our recent out of town when we were visiting Cambridge University's engineering department. Makes the point quite nicely, I think. As a woman in engineering, one of the defining moments in my career was getting my chartered engineer status. I value it and worked hard for my CEng, showing that my level of competence is recognised by my peers. It's very important to me and not something I would give up lightly. It's part of my identity. I know there are some people who didn't have to work quite so hard to get theirs, and perhaps it means less to them. And so they're trying to remove it as one of the basic requirements for joining the Worshipful Company of Engineers. There are those whose career took off because of who they knew, which college or school they went to, or what company their father worked for. But for me, being judged against as objective a standard of competence as we've yet been able to come up with, the Engineering Council's UK spec, allows us to admit a wider range of people to join the Worshipful Company of Engineers, and none of us are here because of who we knew and the circles we move in. I remember with great joy the first time I had a business card with CEng on, and I handed it out during a meeting with clients. The atmosphere changed. I wasn't the girl in the room there to pour the coffee. To have truly enlightened engineering, we need engineers from the full spectrum of society, across all ethnicities, genders, ages, religions, educational levels, etc., so that products get engineered and are of use to the whole wide cross-section of society. One of the ways of having that broad range is to value and promote professional registration, which we can all do, and we should maintain that link as the basic entry level to the company. One of the areas that shows we have a bright future is that the UK is 4th on the recently published Global Innovation Index rankings. This data shows that during the COVID period of 2020, when there was a general economic downturn, innovation investment actually grew at a rate of 3.3%. The report discussed two key innovation waves that will shape our future: a new digital age wave and a deep science innovation wave. And this will lead to innovation in 4 key fields: life science and health, agri-food innovation, energy and clean technology, and transport. While the positive effects of these innovation waves may take a long time to materialise, innovation-driven productivity growth and its effects on all our well-being will be high. Past president of the Institution of Mechanical Engineers, Phil Peel, recently wrote about his visit to the Conservative Party conference. And I quote, "What struck me most strongly was an appreciation of the wider human, social and political ecosystem within which engineering exists. In our profession, we speak a lot about systems engineering to make sure that we're considering the bigger picture. For instance, we know that electric vehicles only make sense if they are supplied with electricity from carbon-free sources and if there is extensive recharging infrastructure. This is all rather obvious. Ultimately, though, it's only part of the story. Any engineering-based activity or project, especially the more strategic ones, needs wide political support in the form of public perception, press views, and lobby group opinion, as well as support in the case of energy consumption, for example, in the form of changed individual behaviour, which may well come about with the increased prices for energy. Very often these factors are ambiguous and contradictory, with no ideal solution, the exact opposite of the inbuilt engineering mindset. The engineer's approach is one of rigour, which in turn leads to dependability and certainty, often in difficult circumstances. For example, we all take flying for granted these days, despite the fact that travelling at over 500 miles an hour at 37,000 feet in air that's minus 56 degrees centigrade and too thin to breathe is fundamentally a rather unsafe activity. But through thorough engineering, we feel quite safe when we do it. Perhaps this mindset is one that could be a useful addition to the political mix, especially at a time when our most fundamental societal challenge, climate change, is so dependent on engineers and engineering. Not every problem is a crisis, a plague or an epidemic, and among the things that happen in the world is that people solve the problems confronting them. You may have heard of the great horse manure crisis of 1894, when cities were drowning in horse manure. London had over 50,000 horses on the streets every day, and the Times newspaper predicted, in 50 years, every street in London will be buried under 9 feet of manure. The terrible situation was debated in 1898 at the world's first International Urban Planning Conference in New York, but no solution could be found. It seemed that urban civilization was doomed. However, necessity is the mother of invention, as they say, and the invention that could not have been foreseen in this case was that of motor transport. Henry Ford came up with the process of building motor cars at affordable prices. Electric trams and motor buses appeared on the streets, replacing the horse-drawn buses. This motor transport has provided many engineers like me with good careers over the last century and a quarter, but new inventions will come along. Just as the horse manure crisis of the late 19th century was solved, and the boredom crisis of the 1960s has been allayed, I am optimistic that the global warming crisis of today will be solved in due course. I am confident that the next generation of engineers will be sufficiently enlightened, passionate and talented to solve the problems that seem so unsurmountable to us today. All we need to do is create the right environment for them to do their work, allow them to learn from our mistakes, and create a more open and tolerant environment that allows for all to contribute to an open exchange of ideas, knowledge and innovation. Nothing can erase an engineering disaster, but no disaster needs to be repeated, as by talking and writing about them we can learn from them, and by learning from them we can make sure they do not recur. George Santayana, one of the most important thinkers of the first half of the 20th century, wrote, "We must welcome the future, remembering that soon it will be the past. And we must respect the past, knowing that once it was all that was humanly possible." Thank you.